Let's take a look at piecewise functions, from evaluating and graphing to domain and range. Piecewise functions are literally given to us in pieces. When x is less than -2, we get the function y equals -2x. When x is equal to -2, we get y equals 0. And when x is greater than 0, we get y is equal to 2x. So it depends on the x value, what y value we're going to get. So when we have to find the following, this is asking us to find the y value when x is -3, we come over here and say, okay, where is x is -3 in each of these three pieces of the domain? -3 falls in this first one because -3 is less than -2. So we're going to use this function and substitute -3 in for that x. When we do that, we get -2 times -3, or +6. For the next one, f of 0. So when x is 0, what is y? So we come over here, 0 doesn't fall in the first one. 0 is not equal to -2. And 0 isn't greater than 0, so 0 doesn't fall in any of these. What that means is that there does not exist, so let me write this, does not exist, a point that has an x value of 0. So we just write does not exist. Let's look at the next one, f of -2. So what is the y value when x is -2? Well, the first one is x less than -2, and it's not that, it's this one, x is equal to -2. So we pulled this y value 0. It really doesn't matter what we have here when x is -2, we just pull this y, there's no substituting to do, we just get 0. So we always get 0 when x is -2. For the last one, f of -1, where does -1 fall? Is -1 less than -2? No, so we can't use the first piece. Is -1 greater than 0? No, can't use that. Is -1 equal to -2? No. So this one does not exist as well. Here's another function. Pause the video and try, see if you can evaluate each of these, and then come back and I'll give you the solutions. So welcome back. F is 0. So here, a piecewise function given to pieces. Look at each of the x values and what it means for the y values for the different pieces they're defining. And they're looking for the y value when x is 0, so we have to decide which interval 0 falls in and then pull the y value from here. Well, 0 falls in this first one, x less than or equal to 0, so we are going to use the function y equals x squared. Substitute a 0 in there, 0 squared is 0, so 0 squared, and you get 0. For the next one, f of 1, where does 1 fall? Well, 1 is not less than or equal to 0. 1 falls in this middle interval. For the middle interval, what it's saying is that y is always 3. Regardless of the x value in here, we always get 3. So this guy is equal to 3. What about f of 3? Well, it doesn't fall in the first interval, the 3. Remember, we're looking for the y value when x is 3. Doesn't fall here. 3 is not between 0 and 2. 3 is not greater than 4. Remember, when your domain pieces do not include the x value for which you are looking for a y, you get then does not exist, which means that there does not exist a y value when x is 3. So this curve does not exist at x equals 3. Try the last one. Y value when x is 5. Find the interval that the 5 falls in. It falls in the last one. So we're going to use y equals x. So we're going to substitute the 5 in for the x, and we just get 5. So that's evaluating functions. It's actually finding y values given an x. Let's take a look now at how we find domain, intercepts, and range, and whether something is continuous or not. So here's our piecewise. We already had this one, and so we're familiar with it, but we want to find each of these pieces. We're going to need to graph this. You need a coordinate plane. And what we're going to do is divide the domain up, this x-axis up for this domain. So when x is less than -2, everywhere from negative infinity all the way up to negative 2 with a round circle because of this less sign. It means we're going to draw this line all the way through when x is up to negative 2 but not equal to it. Do a little t-chart. Y equals negative 2x. And then let's look at the next one. When x is negative 2, y is 0. So we get a point for that. When x is negative 2, y is 0. And then for the last one, when x is greater than 0, we get this function. So let's go ahead and, when x is greater than 0, so from 0, everywhere in this direction, we are going to graph y equals 2x. Remember, with a piecewise function, these graphs don't go everywhere, so we don't draw y equals 0 everywhere, negative 2x everywhere, 2x everywhere. We only get to graph this piece, this y equals negative 2x, where x is less than negative 2. So we're dividing the domain of the x-axis up and saying I'm going to graph that guy over here. So that's what this is asking me to do. Pick the end point, and then pick one x value in that interval, so we're going to go left 1. And then find the y values. You do that by substituting it into the function. So negative 2 times negative 2 is positive 4. Negative 3 times negative 2, so we're substituting in here, is positive 6. So we have 2 points that are on this curve here. It's going to be the point negative 2, 4, and the point negative 3, 6. So let's go ahead and I'm just going to mark it as 4 and 6. This is not to scale. At negative 2 you get 4 with an open circle because remember the x's approach negative 2 but don't reach it. And then at negative 3 it goes up to 6. And so we get this line. Go ahead and label that. That is y equals negative 2x. It makes sense because it's got negative slope from left to right. Let's go ahead and graph the purple piece of our line. We're going to use the end point, which is 0, and then 1 to the right. Let's go ahead and use 1. Well, you can use any x value over here to substitute in to find the y. 2 times 0 is 0. 2 times 1 is 2. So we are going to go ahead and graph 1 point here. It's an open circle, again, because it does not include an equal sign. And then at 1, we're going to get 2. So this line is graphed here. This is y equals 2x. And we are actually done graphing our piecewise function. And so what we get for this here, this point, is occurring for this middle one when x is negative 2, y is 0. So here we have this point. For every x less than negative 2, we're going to graph this line. So every x less than negative 2, we're going to graph this line. For every x greater than 0, we're going to graph this line. And so we're done graphing. At this point, what you see down here, this is all scratch work to get you where you need to be for graphing. The actual graph of the piecewise function is this at the top. So let's go ahead and find the domain now. When we find the domain, we're looking for all the x values. The domain comes from here. So we want, for the domain, everything less than negative 2, so if we have a number line, everything less than negative 2, so we're not including it. Then the middle line is telling us, oh, include negative 2, so we're going to include that x value, fill in the circle. And then the last line is saying x is greater than 0, so everyone in this direction. Reading a number line, we're going to take from negative infinity to negative 2, and from 0 on. This is a solid circle. This is an open circle because it doesn't include 0. And so let's go ahead and write that. We get from negative infinity all the way to negative 2, bracket because it includes the endpoint, union, parentheses, 0 to positive infinity. Now let's go ahead and take the range. The range is asking for the y values that are covered. Oh, so we don't have range written here. Here it is down here. Let's do range next and come back to intercepts. Based on the graph, find the range. So it wants all the y values. So look at the side here and say what y values are being covered. It's including 0, and it's including everyone this way and on in that direction. That's a huge arrow. It's smaller. I don't think I can get a smaller one. There we go. So it's going to be, get a yellow, I'm sorry. Everyone from 0 and up in this direction. So 0 is included, and then everyone up to positive infinity. So let's go ahead and write that. That's going to be from 0, including 0, all the way up to positive infinity. So the reason why we include the 0, here you see an open circle, and there is no point here with y is 0, but this guy has y as 0, so we're going to include that. Now let's go ahead and locate any intercepts. This is where it actually hits the x and y axes. This guy is hitting the x-axis here at -2, so that's one intercept. Nothing hits the y-axis. Remember, that's an open circle. So we only get one intercept, and that intercept is -2, 0, and it's an x-intercept. There doesn't exist a y-intercept. Let's try another one. Go ahead and pause the video, see if you can graph this one, and then come on back and we'll do it together. Okay, welcome back. And let's start with the first line. Remember, piecewise function given in pieces. And so when x is less than or equal to 0, we're going to graph x squared. And so from 0, I'm going to write it down a little farther. Filled in circle because it's less than or equal to 0. We're going to graph y equals x squared. For the middle interval here, from 0 to 2, they're telling you to graph this. So from 0 to 2, but not including 0 and 2. So let's go ahead from 0 all the way to 2, but not including 2. We're going to graph y equals 3. And then lastly, x is greater than 4. So here at 4, open circle, everyone in this direction, x, y equals x. Let's go ahead and find some x values to use and then find y values. Remember, what we're trying to do, we're trying to graph x squared everywhere here on the left, from 0 to the left. We're trying to graph y equals 3 from 0 to 2 in here. And then we're going to graph y equals x when x is greater than 4. So to do that, we're on this interval. It's from 0 less than 0. So let's use 0 as the endpoint, and then just -1. 0 squared is 0. -1 squared is +1, so we get the 2 points, 0, 0, and -1, +1. This is a quadratic, so we should have a little bit of a curve to it as he comes down. And let me label that. That is y equals x squared. Now let's go ahead and graph the middle one. Remember, y equals 3 from 0 to 2. That's this, from 0 to 2. And y equals 3. We don't even really need x values for this one because y is 3 is the line, horizontal, y equals 3. You can go ahead and put the endpoints in 0 and 2. What's y when x is 0? 3. What's y when x is 2? 3. So we get the horizontal line y equals 3. Now let's do the last piece of the piecewise function. Sx greater than 4, we're just going to graph the line y equals x. So that means from here at 4, everybody over to the right. So let's go ahead and pick the endpoint, 4, and then one more in to the right in that interval. Y is equal to the x value, so we just get 4 and 5. Open circle. And it's an open circle because here we have x is greater than 4. Remember, this is scratch work down here, and this is the actual graph of the function. Now from here we can find domain and range and our intercepts. So let's go ahead and find domain. Domain is going to be all x is less than or equal to 0. So including 0 everybody to the left that's less than it, from 0 to 2, so we already are including 0, up to 2 but not including 2. That's what this is saying, not including. So this guy is what we just did. And then let's do the last one, x greater than 4. Open circle, everybody to the right. So really what this left one, we've glued them together, it's really saying all x is less than 2 because it's including everyone here and 0. So let's go ahead and write that. Negative infinity all the way to 2, opens parentheses. Then we went from 4 all the way to the right, which is positive infinity. Let's go ahead and find the range. When we find the range, we are looking for all the y values that are being covered. You'll notice they go for infinity in that direction. They come all the way down to 0 and include 0. You know, here in the center, this guy's hanging out here. This is what's overriding everybody else. This has y values from 0 to infinity. So even though this guy doesn't have a y value on the ends, the y value is covered over here. So this one, even though this doesn't have a y value on the end point because it's an open circle, that y value is covered over here. So it's everyone from 0 to infinity, and including 0. So let's write, oh, that's intercepts, 0 all the way to positive infinity. Okay, so now, last piece, intercepts. Where is this hitting the axis? This far right one doesn't hit at all. It's floating up here in the first quadrant. This middle one is floating as well, and it's not hitting the y-axis because it's got an open circle here. But here at 0, 0, it is hitting the x and y intercepts. So our intercepts are 0, 0, and that's an x and y intercept. So that is it for Piecewise. I hope you are having a great day. And remember, piecewise functions are literally coming in pieces. Hope you have a great day.